Given question, find the moment of inertia of the shaded area about the axis AB. In this question, we have to find out moment of inertia of the shaded area. We will divide this total shape into three parts. First triangle, second semicircle and third circle. So shaded area is equal to area of triangle plus area of semicircle minus area of circle. To find out moment of inertia, we will prepare one table. First column is for shape number. So we have to show the first shape triangle with base 8 cm and height 8 cm. We have to calculate area half multiplied by base multiplied by height. That is half multiplied by 8 multiplied by 8, that is equal to 32 cm square. Now we have to find out the distance in between this AB as well as the centroidal axis. So for that we have to first show the centroid of the triangle. So we will select one point. Now this is the centroid. The distance of the centroid from this height, that is this horizontal distance, is equal to 1 by 3 multiplied by this base. And the vertical distance is equal to 1 by 3 multiplied by this height. Now we will show the axis passing through the centroid. So this horizontal axis is known as XC and the vertical axis is known as YC. Now we have to find out moment of inertia about AB, which is horizontal. So we are going to use parallel axis theorem. So for that we will find out the distance in between this XC and AB because both are parallel to each other. So vertical distance in between them is 1 by 3 multiplied by 8, that is equal to 8 by 3. So we will mention in the next column, that is 8 by 3. Now we know the moment of inertia about centroidal axis XC for the triangle. So it is equal to BH cube by 36, where B is base, H is height. So we will mention here 8 multiplied by 8 cube divided by 36. Now we will move to the next shape, semicircle, which is having base 8. Now we have to show this axis AB. Now how to find out area? So area of circle is pi r square. So this is semicircle. So we will write here pi r square by 2. So I will write here pi multiplied by r, that is 4 centimeter, 4 square divided by 2. This is the area of semicircle. Now we will show centroid. So for that we have to select the middle point of this base. So for this total length 8, we have to select a point at 4. Now centroid is at a distance of 4r by 3 pi. 4r by 3 pi. So here is the centroid. So this vertical distance is equal to 4r by 3 pi. Now we will show the axis passing through the centroid. So this horizontal axis is known as XC and vertical axis is known as YC. Now we have to show the distance in between this XC and AB because AB and XC are parallel to each other. So here R, that means radius. So radius of the semicircle is 4. So 4 multiplied by 4 divided by 3 pi. Now we know the moment of inertia along XC for semicircle. So here is the formula 0.11 r raised to 4, where r is 4. So we will write here 0.11 multiplied by 4 raised to 4. Now we will move to the next shape, circle. Now for circle we have to write area. So here radius of this circle is equal to 2 centimeter. So area of circle is pi r square, that is pi multiplied by 2 square. Now we have to show centroid. So centroid of circle is nothing but it's a center. So center is here. Now from this center we have to show two axes, that is the centroidal axis XC and YC. If we observe the given diagram, then the axis AB is passing through the center of the circle. So if we observe the distance in between XC and AB, then it is equal to 0. Now we know that this moment of inertia along XC, that is pi by 64 d raised to 4, where d is the diameter. So we will write here pi by 64 and diameter is 4 cm multiplied by 4 raised to 4. We will calculate moment of inertia of shaded area by using parallel axis theorem. So moment of inertia of shaded area is equal to moment of inertia of the triangle plus moment of inertia of semicircle minus moment of inertia of circle. So we are going to use parallel axis theorem. So for shape number 1, how to apply parallel axis theorem? So we have to take Ixc1 plus in the bracket A1 multiplied by this distance square, bracket complete. So we have to write 113.77 plus 32 multiplied by 2.66 square. Now we have to move for the next moment of inertia for shape number 2. So here Ixc2, that is 28.16 plus area A2, that is 25.13 multiplied by 1.69 square. Now for shape number 3 we have to subtract this moment of inertia. So we have to take Ixc3, that is 12.56 plus 12.56 multiplied by 0. So here this whole term will become 0. So we have to take here minus 12.56. So when we calculate this, we will get the answer 427.55 cm raised to 4.